Hi, good evening, everyone, and welcome to this revision session for algorithmic thinking in bioinformatics for quiz 2 revision. And I hope this screen is visible to all of you.
Yes, sir.
Okay, thank you so much, and thanks for joining in. So, agenda is to carry out revision session for quiz 2, and what we will do, unlike the other revision sessions, we will go through the concepts thoroughly because we have seen in quiz 1 that a lot of questions they are coming from concepts only, and they are not straight away from the PYQs or the GAs. So, with that, I will start with the concepts of quiz 1 with week 5 and 6 and 7 and 8. Okay. So I hope my screen is visible clearly to all of you. If
Yeah.
anybody is, yeah. Okay. Thank you. Okay. So the week 5 was basically about finding those trees, okay, which are there. Okay. So the first was the distance based phylogeny, and how we do it. If we are using only distance based phylogeny, then if we are giving this matrix and how this matrix is calculated, we find the distances. So distances, how do we find? Okay, distances, these are Hamming distances. Hamming distance. I will just give you an example that if there are two sequences like A, C, C, G, T, C, C, and another sequences is A, C, A, G, A, C, A, then we compare it and we find the differences. So here C, A is different. Here, so this is one difference, and there is this two difference, and this is third difference. So the distance will become 3. So if this is, for example, this is chimp and this is human, so here chimp and human will become 3. That is the example, okay, how you build this distance matrix. I hope this is clear to everyone, how we measure the distance.
Yeah.
Okay. Okay. Then second, then from the first, what they taught us, that first is the distance-based phylogeny, which can work for the additive trees only. So what do we do in this? We find the lowest distance. So from here, what we will do, we will find the lowest distance. So here, the distance between whale and seal is the lowest. So we build this. Now we know that whale and seal it has come. So this is whale and seal, and distance is 2 between them, but we don't know what is the distance. Now we can come to know the second will be chimp and human. Okay. Now what we do, we select one of them, chimp or human, and mathematically we can say that if I draw this, and these are 2 points A, B, then I have to calculate, for example, AW. So mathematically, we can say that AW will be is equal to CW plus WS minus CW divided by 2. So we don't have to remember the formula if we just remember the concept. Is this clear? We are adding this, and then we are subtracting this. So what do we get again? We get this segment, this segment, 2 of this segment, and then we divide by 2. So that's how we get this. Is this clear again? This will help you in understanding. Any doubt in this, anyone?
So it should be CS or CW.
It is CW plus WS minus CW plus WS CS. Sorry, this is CS. Okay.
Okay, sir.
Is this okay with everyone? Because this concept will come handy in future also. So if you can draw this and can make this, so then from what it will come, we will be able to find this limb length. Okay. Now similarly, if I take the same example, I have come to know that W and S are in the same, chimp and human are in the same. This is the distance. This is AB. Now to calculate AS. So what I will do, I will do CS plus WS minus CW divided by 2. So by that, I will come to know the distance of AS. Is this okay with everyone? Aditya?
Yes, clear.
Okay, okay, very nice. So this is the basic
Sir,
concept. Yeah.
sorry to interrupt, but is there a specific reason why we are going from the side of C and not from the side of H?
No, you
From
can
the
go by H also. No problem.
Okay.
You can select H also. So if I will just demonstrate here only. So in this particular example, this is W, this is S, and this is C, and this is H. So we selected earlier C. We can select H also. So for example, if we select H and we have to calculate BS, for example, then it will become HS plus SW minus HW divided by 2, and we'll get the same answer.
Okay, sir. Thank you.
Okay, so we can select either of them. So I've written also here कि now pick chimp or human, and find A, B, and B. So this is the most easiest one, but this works. This will not work on all the trees. Okay, that is the catch. So this is the first one. So wherever in the question, if it comes the distance-based phalogony, so remember this concept. So unfortunately, the week 5 has got a lot of concepts, unlike week 6, 7, and 8. So week 5 we have to go thoroughly. Okay.
Sir, can you please explain it again? How we calculated actual distance?
Okay. So see, I'll just take this example only. So from here we came to know that wheel and sail are the closest, and their distance is 2, but we don't know what is the wheel distance and what is the this distance. Okay. So we make like this. Okay. So we know the structure is something like this, and this are the nodes A and B. Now I want to know what is the wheel limb length. So BW, I select, for example, in this case, I will select human. So it will be HW plus WS minus HS divided by 2. So here from matrix I come to know human to whale is how much? 5. Wheel to sail is 2. Human to sail is 7 divided by 2. So this is 0. So what I do, I put 0 here. Is this okay?
Okay, sir.
Okay.
Now it's clear. Yeah.
Huh? Now it is. I hope it is clear now.
Yes, sir.
Okay. So now I have found this 0, and the distance was 2. So this automatically it becomes 2. Is this clear?
Sir, how? Can you please explain it?
Because wheel to seal is 2,
Okay.
and this is 0. So this becomes 2.
Yeah.
Okay. Now what do I have to do? I have to find like one other limb length here. For example, CA. So for CA, I select, for example, C. Okay. So this will become S to C plus C to H minus S to H divided by 2. Is this okay? Simple mathematics. Ulas?
Yes.
Okay. So now what I find, seal to, for example, chimp. Seal to chimp is 6. Chimp to human is 3. Seal to human is 7 by 2. So this become 9 minus 7 by 2. So this will become 1. 1. And now I don't have to calculate again. So I sealed this chimp to human, I find it is 3. So this automatically becomes 2. Is this okay? 1 and 2. And then to find AB, I can use anything. So CW, for example, I find CW is 4. So here it is 0, 1 plus 0 plus 1. So it will become 4 minus 1. It becomes 3. And now it fulfills all the requirements. We can see. Is this okay? Anybody has got any doubt? I can explain again. Surupi, Ullas, Aditya.
Just a quick recap would be great.
Okay. So I will do again. Okay. So I have selected this. So this is the okay. So what we do from here, we first find the lowest distance. So lowest distance is between wheel and seal. So we make a structure wheel and seal here. Now we know that chimp and human will be here. Okay. Now we know that this distance is 2, but we don't know the limb length. We don't know this distance is, so we have to find. So what we do, we have to find, for example, AW. So AW will be equal to, we select this C, this will be CW plus WS minus CS by 2. Okay. So what we are doing, we are adding this, we are adding this, and we are subtracting this. So effectively, what we are doing, we are selecting this twice. And that's why we are dividing by 2. Is this okay, this concept?
Yes.
Okay. And so we get from here, AW is equal to CW. CW is 4 plus W into WS is 2 minus CS is 6 by 2. So this becomes 6 minus 6 by 2 is equal to 0. So what has happened? We have effectively calculated this as this is 0. Now we know that this distance is 2. So automatically this becomes 2. Okay. Now we come to this structure. The second is this one. So we find CB. CB is equal to, we select, for example, W only. So it will become WC plus CH minus WH by 2. Again, the same mathematics. So this will become WC is 4, CH is 3, WH is 5, and by 2. So this becomes 4 plus 3, 7 minus 5, 2. 2 by 2 is 1. So we get CB is equal to 1. And now we know CH is 3. So automatically this becomes 2. Okay, now we come to the final part. We don't know AB. So for that, we calculate, for example, CW, which is equal to CW is 4, is equal to CB plus AB plus AW. So CB we have already calculated, it is 1. AB we don't know, AW we know 0. Therefore, AB is equal to 4 minus 1 is equal to 3. Okay, that's how we have found the entire structure. Is this okay? Hello?
Yes.
Yes.
How do we go to know that we have to put a CW and WS in the first part? Like if we are putting AW equals to CW plus WS minus CS. Like
Okay.
how do we know how to take this combination?
Okay, so Ullas, here we can select either C or we can select H also.
And what about W? Like
Okay.
why we are taking W along
Because
with C?
I'm just again trying to find this limb length. Okay. If I'm trying to find AS, for example, so I will give you an example. AS will become, if I select chin, so this will become CS, C to S plus W to S minus C to W by 2. Okay. And if I'm not selecting C, I'm selecting H. So AS will become H to S plus W to S minus H to W by 2. So I can select anything.
Okay, sir.
Okay. Anybody, any doubt? Okay. I think somebody is trying to come in. I have to let him in.
Suppose there are 5 species instead of 4. Actually, in their lecture, they continuously they discussed about 4 species only.
Yes.
But in questions, they are giving 5 species.
Okay, so that also we'll solve it. Yeah. First we
Diagram we
understand
can draw, but is there any concrete method for that?
concrete method. I think the nearest neighbor which is there, it is the best like, thing to solve that.
We can draw by applying our logic, but whether that would be valid or not, I don't know.
I think the nearest neighbor will be the best one to achieve that. This is the first one, which is the
Now, like if it is 5 are there, so 2 cherries we can make, and fifth one, how do you represent that?
so if
Here
there are
AB is the internal edge, then how many internal edges will be there in that case? And,
okay, so the PYQs, okay, Jagan, we will come later on. First, we
Yeah.
understand the concepts, and once we build up the concepts, then we will be able to answer okay, those questions.
Okay.
Okay, so we build the concept first. Okay, so this is the easiest concept which is there to understand. Okay, I hope this concept is clear to everyone.
Yeah.
Okay. Now we come to the next concept. Next concept is that instead of doing all this, we find the limb length. Okay, so limb length, okay, how to find it? It is the same formula which is there, what we had used earlier. So if this is the structure, it's a different color. So if this is the structure, so what do I do? I have to find, okay, for example, this limb length. Okay. Now taking all, I don't know whether it is okay. For example, I'm selecting for whale. I don't know whether it is seal. It can be anything. It can be seal, human, chimp. Similarly, here it can be seal, human, chimp. Similarly, here it can be seal, human, chimp. So I use this formula that to find this limb length, I use the same. That, for example, if here it is seal and here it is human, so I use the same concept. That's why I was putting emphasis on that method. So it will become min. So one by one, I change okay, all these positions. So for example, here I have put SH. So this will become SH plus WH minus SW by 2. This is one combination. If it is here is human, I will put human, for example, S, I have human 2, chimp plus chimp 2, W minus H 2, W by 2. Okay. And then I take another combination. So I have taken seal human and human chimp. So I'm left with seal chimp. Seal chimp plus WC minus SW, it will become WC by 2. So here all these three combinations are available, and whatever is the minimum out of that, that will be my limb length. Is this concept okay, understood by everyone?
Yes.
Okay.
So the last one would be WS, right?
WS. So I'm putting S.
At last. So
Yes,
it's minus WC.
yes, it will become WS. Yeah. Okay. So here what I am doing, I'm putting S first. I'm putting, so I'm taking one combination S and H, number one. Then I'm taking H and C, this is 2. And then third, I'm taking chimp and C, this is 3. Okay. And accordingly, you can put together these things. Is this okay? And whatever the minimum comes, it will be the limb length.
Okay.
Okay. And now once I do this, so once I have found the limb length, so this is the formula which I have condensed okay, while explaining. So I find okay, limb lengths for everything. And then I know the limbs. Okay, limbs are like this. So I have got limb of chimp is 1, limb of whale is 0, limb of human is 2, limb of seal is 2. So what I do now, how to join? So what do? You select anyone. So for example, you select, for example, chimp. So limb length of chimp is 1. So I have put a limb length of chimp is 1. Now, what do? Use chimp, you come to chimp and you remove this chimp column wise and the row wise. So, and you do the -1, so you remove. So you have got now, this is known as, this one, when you do the -1, this is known as bald matrix. Bald matrix. And this is known as the, while you're selecting, this is known as trim matrix. If this comes in the question, like in the GA, they had asked this question. So trim, we get this, for example, the trim one we have got. And now that from the trim one, whatever is the lowest, so this is the lowest. Now you know that this is the one which will be the close to everyone. Sorry. Yeah. So wheel and seal, whale and seal you have got. So now wheel and seal, whale and seal you have got, and now just put the limbs now. So it is the easiest part. Is this okay with everyone? Bald matrix, trim matrix, how to find the limb length? Anyone, any doubt here? I can explain again also. Ullas, I hope it is clear.
Sir, little bit explanation more required.
Okay. So what we'll do, we will do a full example of this. Okay.
Okay, sir.
We'll select this only and we will solve it. Okay. So I have to find here, for example, the limb length. Okay, limb length. So I have to find a limb length of, for example, W. So I denote it as LW. So this will be equal to minimum of and here you put here V. Okay. Now I don't know what are there. So it can be seal here, it can be human here, it can be chimp here. Similarly, it can be seal, human, chimp. It can be seal, human, chimp. Okay. And what we are doing, we are using the same formula that to find this limb length, what you have to do, you have to add this distance. You have to add this distance, this one. You have to subtract this distance divided by 2. So you get this limb length. So we have to find the limb length, which is the minimum most. So I select, for example, seal and human. Okay, so it will become minimum of seal to W plus W to human, because I have selected W to human, minus seal to human divided by 2. This is first combination. Second combination is I select seal and chimp. So this will become seal to W plus chimp to W minus seal to chimp by 2. Now I have got third combination, only the third combination which is remaining. It is human and chimp. So it will become human to W plus chimp to W minus human to W divided by 2. So we can find out these values. So seal to W is 2, W to H is 5, seal to W is 2. I have made some mistake here. Seal to W is 2, W to H is 5, and seal to W is 2. So divided by 2 will become 2.5. Okay, number 1. Then I have selected seal and chimp. So seal to W is 2, chimp to W is 4, minus C.
Yeah, actually, the formula SW minus SWR, that mistake there you are done.
Where?
The first one. SW plus WH minus SW. That
Yes. Yes.
It would be SH, sir. Instead of minus SW, it would be
yeah,
minus
should
SH.
be FH.
Okay. SH. Sorry. Thank you for correcting me. So S2 human is 7. So this becomes 0. Okay. And once you get 0, you don't have to calculate anything because 0 is the minimum most because it cannot be negative. Ullas, is this okay?
Yes, sir. Okay,
Okay.
clear.
Okay. Now, so we have got only this limb length, but we don't know what else is there. So I will take another one. So we go to, for example, LS. We find for LS. So this is again, if you don't remember this formula, so formula is minimum of, I am finding for Li, okay, and I have selected J and K. I have selected 2 limb lengths, so this is I, this is J, and this is K, and I can this JK different combinations. So formula is Li is equal to minimum of distance of Ji plus distance of Ik minus distance of Jk divided by 2. Okay, and various combinations you apply because J and K can be different, and divided by 2 because this we are taking mathematically twice. So you divide it by 2, so you get all the limb lengths. Is this okay, Ullas?
Yes, sir. Okay, clear.
Okay, anybody any doubt about this? And when you get the limb length, so how to build it now? So limb length, for example, you have got, okay, I'll just give an example here only. So you have found, okay, this limb length. So how to build the tree from there? So we have got these limb lengths, and we have got that matrix also. So this is the matrix. So the first one, your first step is to make the bald matrix. So bald matrix is nothing. Bald matrix that you take any one of the limb. So for example, if you take chin, so what you will do, you take the chin, this one, and you take the row and you take the column and you subtract -1 from all the entries. Okay, so it will become -1, -1, -1. It will become -1, -1, -1. And this remaining matrix which is there, this is known as the trim matrix. This is known as trim matrix. And from this trim matrix, whichever is the closest, that is your first combination. So in this case, we know that seal and veil, they are the closest. So what do? You put the seal and veil. And now you the limb length. So seal is 2, veil is 0. Now from here directly you can build that chimp and human will be here. You know the chimp limb length, you know the human limb length 2, and using like we did earlier. So chimp to seal is 6. So this is 2 plus 1, 3. So 3 will come here. So how to build the tree is like this. Is this okay with everyone?
Yes.
Okay. So we have seen it.
What is the usage of bald length here? Bald limb?
Balding is just a concept. Okay. So there are 3 steps. First, you find the limb length.
No, that is I understood. Means what is the purpose of getting this bald limb?
Balding means that
from the trim limb, from the trim matrix, trim, we can find out the closest. That is
yes.
So what is the purpose of bald limb?
Bald matrix, okay, there is no use. Bald matrix only means one thing. For example, when we did the chimp, okay, and when we removed it, so chimp has come here, okay, with a value of okay, -1, -1. There is no use in calculation. So conceptually, this is the meaning.
Okay.
Okay, so in the question, if it comes, okay, that find the bald matrix.
That is okay. Question comes,
Okay.
it's okay.
Yes. Otherwise, practically, there is no use.
Okay.
Practically, it is only the trim matrix.
Yeah. Okay.
Okay, you find the limb length, you find the trim matrix. So these are the 3 steps which we have to follow.
Okay.
Okay, is this okay with everyone till now? So we have seen till now one distance-based Faligny, distance-based, and then we found how to find the limb length. Okay, and limb length again at the cost of repetition, I will repeat again here that this is nothing, just we have to understand this basic mathematics. So if this is the structure, we don't know what is the structure, and we are calculating, for example, these are the points, for example, A, B, C, D, E, F, and we have selected that I have to find the limb length of A. Okay, so I don't know whether this A, B, C, D, which are there, sorry, this B, E, and F. So this can be B, E, or F. This can be B, E, or F. This can be B, E, or F. So what I do, I find one by one, use this concept, this one, and one by one, I select different combinations and I select the minimum of distance of, for example, BA. If I selected, for example, so combinations can be what? Here can be BE, or it can be EF, or it can be BF. These are the only 3 combinations. So I select all the distances. So I take BE. So this will be BA plus AB BE AE minus BE divided by 2. I take the second combination EF. So it will become EA plus AF minus EF divided by 2. Third combination is BF. So it is BA plus AF minus BF divided by 2. So whatever the minimum comes, okay, that will be the limb length of this. Is this okay, Ulas? Now?
Yes, sir. Clear.
Okay. So can we go to the next concept? So we have found the limb length. Now we go to the second concept. Okay, so this I have written. Okay, the third one was the UPGMA. It is a heuristic based again. So heuristic based, how do we do? Somebody had asked in the WhatsApp group also that how to solve that. So what do you do in the heuristic base? The step 1 is to select the lower distance. So this is your matrix. So first you find the lowest distance what is there. So in this case, for example, it is 2, 2 between I and L. Okay, sorry, it is between K and L. So what do you do? First step is there. So I'll solve from here on. So I will cover all the steps in this one by one, because this can come in the question. And okay, so what do you do? The first step is that you put all the nodes on your horizontal axis. So you got 4 nodes, I, J, K, and L. Step 1. Okay, step 1. Put all nodes on horizontal axis. Number 2, step 2. Find closest distance, minimum distance, and nodes. So here we know that K and L, they have got the closest distance 2. So we know this K and L, they have got closest distance, which is 2. And what do? You divide this 2, and there are nodes 2 by 2. So you get 1, 1. So distance between K and L is 2. This is the first step. And just for the reference part, you make a y-axis also, and you can mark it, okay, here. This is 1. This step is clear to all of you?
Yes, clear.
Yeah.
Okay. Okay. Now step 3. Now when you know that K and L, they are here, so remaining node will be Ij. So Ij distance is 3. So you apply the same thing. I and J is 3. So this becomes 1.5. This becomes 1.5. And this height is 1.5. So this is okay.
Yes.
Okay. Okay. And now what do you do? So this which it was there, IJKL. So next step is to reduce this matrix. Now what we did, we had found KL is one node. Okay, they are converging to one node. So what do you do? Now you convert it to IJ and KL. Okay. And how do you do that? How to find the distance between I to KL? So I distance of I to KL will be I to KL will be equal to distance of I to K plus distance I to L and divide entire thing by 2. Okay. So distance of I to this will is like 0, 0, 0. I to J remains same 3. I to KL will be distance of I to K is 4. I to L is 3 divided by 2. So here it will get 3.5. Now here J to KL will be J to K 4 plus 5 by 2 is equal to 4.5. And this is a symmetric matrix. So all these values will come here. Is this okay? This part?
Yes.
Okay. Now the third step is, now you find distance of I to J and to K to L. I to J and K to L. So distance of I to J to K to L will be distance of I to KL plus distance of J to KL divided by 2. Is this okay? Is this okay? This one?
Yes.
Okay. So this will become, so see, distance of I to KL was 3.5. Distance of J to KL was 4.5. So this is 0 and 0. So this will become 3.5 plus 4.5 divided by 2. So this becomes 4. Okay. And the meaning of this 4 is that whatever you are getting in last, this 4, so this 4 you divided by 2. So you get 2. So your root node which is there, we had made come till now here. So your root node will come here and its value is height is 2. Okay. So this distance will become 2 minus 1.5, 0.5. This distance will become 2 minus 1 is 1. So this how we complete the trick. UPGMA. Is this okay? Or shall we solve another example on this?
So can you explain from the 0.5 node? That you
So see, this height of this is 2. Height of this is 1.5.
right.
So this node height will, this distance will become 2 minus 1.5. Okay.
Right. Yep.
And this is 1. So this will become 2 minus 1.
So how did we decide that the height is 2?
This had come now 4. So 4 divided by 2.
Okay, right. Okay.
Okay.
Mhm.
Okay. We solve another question also on this. So remember this, first of all, that it might not be possible to use this UPGMA because it is a heuristic method. So heuristic क्या होता है? That we found the distance based phylogeny and we also saw heuristic based. So their pros and cons are like that. The distance based Phalogony can only make tree for additive trees. Additive trees. Okay, it cannot make for non-additive trees. Whereas heuristic one, which is there, it is making on the basis of heuristics, so it can make for non-additive trees also. But when it makes for additive tree, if it will make, it might not match to the best tree. Okay, which can come from the distance based. Is this okay, this concept?
Yes.
Okay, Jagan, can you throw some light on this? Am I right? Okay. So we have seen this. Okay, we can see another example also, just at the cost of repetition. So this is another example. I will take this just to know those calculations. So this is another example. So these are for A, B, C, D. So what do we do? First step, we find the lowest distance here. So lowest distance we find is 4, and it is between A and B. So what do? We put all the nodes on the horizontal, A, B, C, D, A, B, C, D. So AB we have found 4. So this is 4. We divide it by 2. We do give equal contribution to everyone. We make a vertical line. So this is 2. Now we know that C and D will be the another one. So CD we find the distance. So CD is 5. So we know that CD is at 5, which is 2.5. This is 2.5, and here it comes 2.5 and 2.5. Now we have to reduce now to this. For example, we had selected initially AB, so we will select C and D to AB. So we select C, D, AB, C, D, AB, make this value 0. C to D, we know C to D is 5. And we have to calculate C to AB. So it will be C to A plus C to B divided by 2. So C to A is 8, C to B is 6. So 8 plus 6 by 2 is 14, it is 7. D to AB, so D2 is 8, 10, D to B is 10, so this is 10. 10 plus 10 by 2 is 10. And it is a symmetric matrix, so we get 7 here and we get 10 here. Now we reduce it to A, B, C, D. A, B, C, D. So here A, B, C, D is like AB to C plus AB to D by 2. So AB to C was 7, AB to D was 10. So this will become 10 plus 7 by 2, 8.5. 8.5, 8.5. Then you take divided by 2 this, it will come 4.25. So your root node will be at 4.25. This is your root node. And now to find this distance, this will be 4.25 minus 2 because this is 2. So this is 2.25. This is 4.25 minus 2.5. This will become 1.75. So this is how you make the trick. I hope this is clear to all of you.
Yes, yes.
Now we can do it. Yeah.
Yes.
Yeah. Okay. So we have covered 3 concepts till now. Distance.
Sir, can you mention how you got 8.5 one more time?
Okay. So 8.5 was A to A. We had to find distance of A to B to C to D. Okay.
Yes.
So this will be distance of A to CD plus distance of B to CD divided by 2. So distance of A to CD, sorry. So we had already AB and we have to find to CD. So it will be distance of AB to C plus distance of AB to D divided by 2. So distance of AB to C was 7. Distance of AB to D was 10. So 10 plus 7 divided by 2.
Okay.
Okay.
Yeah.
Okay. Yeah. So now we go to the neighbor joining theorem. Neighbor joining theorem is slightly evolved. It has got some steps and we have to remember these steps. So in the neighbor joining algorithm, what we do, we have got this distance matrix. From this distance matrix, we first step 1 is to make D star. And how we make this D star? That you take, first of all, make a new column which is known as total, and you take the sum total row wise. Okay, so these are the totals row wise. And now for D star ij, use this formula. D star ij is equal to n minus 2 distance of ij minus ti minus tj. Okay, so if I have to calculate, for example, this dij. Okay, so dij will become n minus 2. So there are 4. So it will become 4 minus 2 into 13 minus ti minus 56 minus tj is minus 38. So this becomes 4 minus 2, 2, 13, 26. 26 minus 56 minus 38. So 26 minus 38 will become minus 12. Minus 12 minus 56 is minus 68. Okay. So for all these, okay, you calculate these values and then you will get the D star. So I have calculated for all here, and from here you get the D star. So this is your D star. Is this okay with everyone? That's step 1. Okay. Now from this D star, what do you do? You select the lowest entry. So lowest entry, for example, is minus 68. So this is between what, K and L. So now from this, you select the lowest entry. And first you find the delta. So delta value is, for example, if I have to find delta of ij, it will be equal to T of I minus T of j divided by n minus 2. Remember this, it is n minus 2. Is this okay? This one?
Yes.
Okay. And third step is, this is step 2. And third step is, step 3 will be equal to, now you find the length of this, the length of limb length of I and j by using the formula length of I, length of j is equal to d of ij plus delta by 2, and j will be d of ij minus delta by 2. So by this you find the limb length of both. Is this okay?
Yes.
Anybody, any doubt in this?
Step 1 is compute D star, second is compute delta, and third is compute limb length.
Yes. Okay. And then fourth step is that, what do you do? Now you update your matrix again. So update matrix is, now you had one 4-star matrix. So what do you do? Now you use the same concept which we used earlier. Distance of Kn will be distance of Ik plus distance of Jk minus distance of Ij divided by 2. So this is a new formula. Okay. And then you reduce that 4-dimension matrix now into 3-dimension matrix. And now again you follow the same steps, that you find total, you find D star, then you find delta, and then you find the limb lengths. Is that okay? Can we use shall I solve one question on this? So when we'll come to
that would clear.
yeah. So I will solve it here only. So see, this is your matrix. I hope okay, my screen is visible, clearly visible to all of you.
Yes.
Okay. So this is your D, for example. From here, what we did, we found total. So this is the T. Now for every entry to build the D star, we make that this formula D star Ij is equal to n minus 2 into Dij minus Ti minus Tj. So I have calculated for Dij, Dik, Dil using this formula. I got these entries. Then I got for Djk and Djl, same formula, got these entries. And last one DKL, so got this entry. So this is your D star. So from this D star, I selected the lowest value, which is minus 68. So minus 68 now, step 2 is, this is DKL. So this is the formula. So for DKL, delta will become T of K minus T of L divided by N minus 2. N is 4. 46 minus 48 divided by 2, it comes minus 1. So now third step is limb length of K and limb length of L. Limb length of K is DKL plus delta by 2. Limb length of L is DKL minus delta by 2. Delta is minus 1. DKL here is 13. So it will become 13 minus 1 by 2. It will become 13 minus 1, which becomes plus 1. So I get the limb length of K and L. So this is K and L. I have got 6 and 7. So this is first step. Second step is now that this matrix, which was there earlier matrix, I will copy it here. Paste it. Okay, chota sa. Okay. Now, using now this update matrix, what I have to use, this formula is there. So K and L I have joined, remaining are I, J, and this KL I make into one new entry, which is known as M. And the formula is the distance of K to M, for example, or distance of I to M. Distance of I to N is equal to distance of, I'm making, for example, I to K plus distance of J to K. This I and J, which are there, minus distance of Ij divided by 2. Okay, so just see here, distance of IM I have to calculate, KL I have got. So what I have to do, I to this N comprises of KL. So what I do, distance of I to K, which was there, K is the first entry. Distance of I to L is the second entry, minus distance of KL. So it is very, very similar to your initial concept that this is I have found K and L are 1. So what I'm doing, I to K plus distance of I to L and minus distance of KL here I'm doing. So it is different. Earlier, what I used to do, this plus this minus this. Here I'm doing this plus this minus this. So I'm finding this distance, this node distance. So this is the reduced form. So I have found distance of I to M like this, which comes 15. Then distance of J to M, same distance of J to K, J to L minus distance KL divided by 2, 6. So this is your reduced format. And now what do you do? This reduction matrix, which is there, again you find the total. And again you build the D star. So this is your D star, which you have built. And from this D star values, which is there, so we had found KL. Now here you select only I and J. And Ij limb length you find. So effectively your neighbor theorem also is calculating the limb lengths. Okay. Earlier also we were deriving the limb lengths. So, but this neighbor theorem, it also works for non-additive trees also. Is this okay with everyone?
So will it be specified in the exam which method we have to use to calculate?
So like in the GAs, okay, they have asked specifically that you use this and find this. So in some, okay, you have to use the additive phylogeny. Neighbor is the one, if you cannot find answer from anything, neighbor is the most evolved algo which you can find.
So, but more or less the answer would be same by all algorithms,
Yes,
right?
yes. But heuristic and the additive phylogeny, they can give you different answers, like I covered earlier.
Okay.
Okay, the heuristic is based on the heuristic. So, like I just show you here, when you build the heuristic, so you assume that these distances are same.
Right.
2.5, 2, 2, which in real term they can be different.
Got it.
Okay. Yeah.
Okay.
Unfortunately, थोड़ा week 5 में there are a lot of algos, so that's why थोड़ा सा वो लगता है. So now what we have do, we have covered again now 4 concepts again till now. So what we have seen distance additive distance. Then we solved the UPMG, and we in between we had solved another thing also, and okay, this which one? Limb length, है ना?
Heuristic also we solved.
This is UPMG only.
Yeah,
Heuristic. Okay. So these are the 4 main methods okay, till now. And the 4th one is the parsimony distance. So parsimony distance is easy. Just we'll look into it. So parsimony distance is when you build a parsimony distance. ये थोड़ा सा वो है, तो मैं इसकी concept आपको समझा देता हूँ. So what do you do? So this is one sequence which is there, given to you. I hope okay, they don't ask evolved question. In the GA, they have asked a very, very simple question on this, but I'll solve it here. Okay. So this is one sequence, and you have to build, and you have to find what is the ACGT score. So they're going CC, ACC, GGTC. So what do you do? One by one, you compare it. You can compare it with ACGT, 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 or so I will cover the concept here. So for example, here it is C is given, but if I compare it, for example, A, that here it was A. So if I compare it with A, it will give me 0 score. If it was here A, so it is 0. If, or I can just start from here, that here it is given C. So I select A, C, G, T here. So it is selecting with C, and the difference with ACGT here for the left side is 1, C is 0, G is 1, T is 1. Here again, it is ACGT, it is 1, it is 0, it is 1, 1. So final score becomes ACGT 2022. This step is clear to all of you? This one?
Yes.
Okay. Now I do for the same here. So here the difference is this is A and this is C. So if you do like this only, so it will get A 0, C G T, C will become 1 1 1. It will become A C G T. It will become 1 0 1 1, and you add it, so it become A C G T 1 1 2 2. Is this okay?
Yes.
Okay. Now we come to the same. So this is GT, GG, so it will become 2 ACGT 2202, and here it is TC, so it will become ACGT TC, so 2121. Is this okay with everyone?
Yes.
Okay. Now I have to build now from this node. Okay, I come to this node from here and here. So here I have got ACGT 1, 1, 2, 2. Now pay attention here slightly. So what I do, I select first of all, for example, A here. Okay. And if I select A here, I get one left score, I get one right score. Right score. So if I got A here, this will remain 2. ACGT, it will remain 2. This C will become 1, G will become 3, T will become 3. Is this okay?
Yes.
Right will become 1, 2, 3, 3. Is this okay? And what I do, I select minimum of this and minimum of this, add both of them to get the value of A. So minimum is here 1, here is 1. So A becomes 2. This step is clear?
So right side will be 1133, right?
Why? Because if I'm selecting A, so C will not match, C will become 2.
Okay.
Okay?
Hmm.
Okay. And I'm selecting the minimum of this. So minimum is 1, minimum is 1, 1 plus 1 is 2. Now I do again now for the same
Sir,
step.
can you re-explain that minimum step? How did it become 2?
Okay. So I'll do for C and okay. So
Yeah.
you take C. Now when you correlate with C, it will become A3, C0, G3, T3. Left, right, it will become, if it is C, here it was the value I have forgot. Oh, I have rubbed it. So it was
1122.
A1, A1, C1, G2, and T2. So here it will become 2, 1, 3, 3. Okay. So what is the minimum value here? 0.
Yes.
What is the minimum here? 1.
1.
So you take the sum of minimum plus minimum. So 0 plus 1 is 1. So
1.
C becomes 1. Okay?
Understood.
Okay. Now you do for G. So G, what it will become? G will become 3, 1, 2, 2. 3, 3, 1, 2, 3.
Yes.
And here it will become 2, 2, 2, 3. Minimum is 1. Minimum is 2. So G becomes 3.
Yes.
Okay. Now we come to T. T will become 3, 1, 3, 2, 2, 2, 3, 2. Minimum is 1. Minimum is 2. So this also become 3. Is this okay?
Yes.
So we have completed here. So at this node, I get 2, 1, 3, 3. Now I use the same step for this. One by one I select. So I do for A, for example. So you just have to find, like there is a shortcut also, that if I select A, the minimum most will be 1. Here minimum most will be 1. So it will become 2. Sorry, minimum here will become 2. So A will become 3. Is this clear? Or shall I solve it? So A I have selected here. A left, it becomes 2, 3, 1, 3. It becomes 2, 2, 3, 2. Minimum is 1. Minimum is 2. So A becomes 3. Now I select C. C becomes 3, 2, 1, 3. 3, 1, 3, 2. Minimum is 1. Minimum is 1. So C becomes 2. I select G. G will become 3, 3, 0, 3. 3, 2, 2, 2. Minimum is 0, 2. So G becomes 2. I take T. T becomes 3, 3, 1, 2. 3, 2, 3, 1. Minimum is 1, minimum is 1. So this becomes 2. Is this okay? This one?
Yeah.
Okay. And now we build the final route. So this is the final route. We select again one by one. So I got 2, 1, 3, 3, 3, 2, 2, 2. So I select, for example, A. So I write A, C, G, T. I select A. So A left will give me 2, 2, 4, 4. Right will give me 3, 3, 3, 3. So the lowest is 2, lowest is 3. A becomes 5. I select C. It gives me 3, 2, 4, 4. Here it will give me 4, 2, 3, 3. Lowest is 2. Lowest is 2. G, C is 4. Now I select G. 3, 2, 3, 4. Here it will give me 4, 3, 2, 3. 2 and 2. So it becomes 4. Now I select T. It will become 3, 2, 4, 3. It will become 4, 3, 3, 2. 2 plus 2 is 4. 5, 4, 4, 4. And can somebody tell me what is the meaning of this? What we are trying to achieve, basically? Conceptually, what we are trying to do by this parsimony? Anybody? Any idea, Jagan?
Evolutionary tree.
It is not evolutionary tree. We are trying to find how many mutations have happened.
Yeah.
So over a period of time, how many mutations at how many places the mutations have happened. So we are trying to find that these distances. Okay, that A, how many times it has changed. Okay. So with this week 5 is finished, okay, shall we do the GS of this week 5?
Yeah.
Fortunately, they have not asked us okay, to build okay, this parsimony score in the GA, but if it comes in the quiz too, so we know how to find it. Okay, so we go to the GS of week 5. So they had asked okay, only this parsimony score in one of the GA. They had given TATAC, TAC, TATAC, and TATTC, and to find the parsimony score. So in the parsimony score, what do? You put okay, all these sequences. So first of all, you try to find that which should be here, which has got the least mutation. So if you select TATAC, so it has got only one mutation here. Similarly, the best one will be TATAC here because it has got one mutation here and one mutation here. So the best is TATAC. And similarly, it will come TATAC here. And now with this 4, you find the parsimony score that where it is it's got differences. So here it is 0, here it is 1, 1. So this is known as parsimony score.
Sir, how did you get that there's only one mutation in
so if you select, okay, for example, TATAC, so this is same, and here only there is one mutation is happening at A.
So that is what. Okay, yeah, got it.
Okay, and here also it is 1. Here also it is 1. So your parsimony score is 3.
Okay, sir, got it.
Okay. GAs are slightly easy, so they have asked in one of the question too. Consider the following hypothetical they have given.
Sir, can we again go back to the previous example that that parsimony score? We are just calculating the first. Achha, both are TATAC. Okay, understood.
Yes.
Okay.
See, finally,
this will be 0, 0. Yes, this will be 0, 0. Yeah.
Yes. Okay. So first question of the G is finding the distance matrix that we can do easily. We have done Hamming distance calculation and to put it in. The second question is, for example, somebody had asked me what to use. So in the question they have given that you have to use the additive distance matrix. So we know how to use the additive distance matrix. So first, what do? You use the lowest one. So you know that this will be the one. And then using the same formula which we had explained earlier, you find other distances. Okay. Then the next question is about the limb length. We have seen the formula of the limb length. We can do it easily. So limb length, remember this same concept, that if you are to find the limb length, then one by one, for example, I have to select for this W. So then one by one, you put all the combinations, ABC, 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 and find the minimum distance which you get for this. Using the same formula, add this part, add this part, minus this part divided by 2. That is the limb length formula. And once you get the limbs, okay, then you can make the bald matrix, then you can make the trim matrix, and from there you can build the tree. Okay, for example, this is the question. Consider the additive matrix they have given, and considering Z limb, a bald limb, find the corresponding D bald. So in here they have given this Z is the bald limb, and they have asked us to find the D bald matrix. So in the D bald matrix, what we have to do, we have to find first of all the limb length of Z, and then we subtract that distance from the row and column of Z, and then you find the D bald. And when you remove that row and column, you get the D trim. Next question is about the mean squared error. It is very easy, so there is no problem. And there is another question on UPMG. So I am expecting that this kind of question will definitely come. It was covered in the live session also. So please try to build this UPMG. Heuristic method I have explained in detail, so you will not face any problem. Okay, another question is on the neighbors. So neighbor one we have solved. They have asked onto to build like a D star. So D star, please remember formula of D star ij is equal to n minus 2 into dij minus ti minus tj. If you remember this formula, you can build the D star. Is this okay?
Yes.
Okay. Then last question was about the this parsimony score. So you have to find the parsimony score. They have given all the notes which they have given. So what you have to do? So GGTCC, no mutation is taking place. GGTCC, only here the mutation has taken place. So to find the parsimony score, you have to find the differences only. So here one, here is one, here is one, is same. So parsimony score is 3. Okay. So is this clear? Okay. Any doubt in week 5?
No doubt.
Yeah, week 5 is slightly lengthier, and there are 3-4 concepts put it in the same week 5. That's why it looks very lengthy. Otherwise, rest of all the weeks are slightly small. So can we take a 1-minute break, okay, to have a glass of water?
Yeah.
Okay. Thank you. I'll just. Hi, shall we start for week 6?
Yes.
Okay, so before I do that, I will just take a minute to build some space in my drive. Otherwise, this session will not get recorded. Okay. Okay. Now we move to week 6. So week 6 is a slightly easy. It is about the pattern alignment problem. So we are given a genome and we have got a small reads. So how to align that reads to genome? So that is a problem. So first concept in that was to build a trie from the read secure. So we have got all the read secure, so we can make a trie from that or tree. So what you do, for example, these are your reads. So you build a trie from that. And remember, when you make from the patterns, there is no dollar sign in the last here. So is this clear here? Shall I give you one example for this?
Yes, one example.
Okay. So if I just take this example, a very tiny example. So I have to make from these patterns. Okay, these are the patterns which are given. And I have to make a trie from here. So what do? We start here from root node. Root node is empty node. So first we make a banana, for example. So B A N A N A. Second is pan. So this is pan. This is pan. This is and. This is nab. And this is antenna, for example. So I come to A, I come to N, and from here I take T now, E, N, and A. Okay, similarly, bandana. So I come to B, A, N, and from here I come to D, then A, then N, bandana. Okay, then is ananas, ANANAS. So we had come to AN, so we come take A and AS. So this is how you build the pattern trie. This okay?
Yes.
Remember this, there is no dollar here. Okay. And you can pass it to now to genome and to find this. So this was the initial thought, okay, what they tried. And then the second concept they came that instead of this, what you make a suffix tree. So how do you make a suffix tree? This I will this is the suffix tree. So in the suffix tree, what you do, you make from the genome. So this is your genome, for example. This is your genome. So the step one is you add dollar in last. Okay. And now what you do, for all the combination of this, you make the tree. So how you build this tree? So first will be, for example, the first will be full banana bananas. So it will become, I will draw here. It is P, then A, then N, then N, A, N, A, N, Panama, and M.
Yeah.
Panama, bananas. Dollar. And in last, okay, you do keep a dollar. Remember this, dollar comes last. P, A, And that's the last one. And then you make for the next one. So next one will become A. So I'm deliberately making A का थोड़ा सा बड़ा because A के ज़्यादा आएंगे. So this is A. Then anama bananas. Bananas dollar and last. So you make it like this. Then next one is your nama bananas. So nama bananas I will make here, and nama bananas. Next one will be amama bananas. Amama bananas. So we have come A here. So from here we can take here and we can make amama bananas. Anama. So sorry, this was anama. So anama, A and A, and from here you take anama bananas. Now next one is Panama. So we have built amama bananas, mama bananas. So M will come this M. Mama bananas. Now we come to bananas. Abamanas. So here we have got A. So we make AB bananas. Then we have got bananas. So do we have B anywhere? We don't have B. So we make a new B here. We make a B here. So remember, dollar comes in the last. And then we have got ananas. So A and A, and from here we make a ananas. Then we have got nanas. So do we have nana? So we have got N A, and from here we can spread nanas. Okay. Then we got NS, A and A, and from here we can make it S and dollar. Then we have got AS, ananas, then NES. So NA, and from here NAS dollar. Then we have got AS. And last one is S dollar, which will be the new one. So this is S dollar. Remember, we don't make for dollar. The last one which is there, we don't make. So this is the suffix second. This is the first step before suffix tree. And now to build this suffix tree, what do? We make, for example, this entire thing which is there. I'll just copy it from here. And now for the storage purpose, how can I make it efficient? I can make a root node, and I can make one as full as Panama bananas. Panama bananas $. So this entire thing has come into one. Okay. The next one, for example, is this. This is also, so I come to the next one, for example, A. So here A will come first, okay? And from here, A, I can make one string as simple A bananas $. From here, it is also AS dollar is also there. So I can make one AS $. Baki, it is coming to N A, and from here I can make nanas $, nanas $, ma bananas $.
It should be yes dollar, right? After
AS. This one is the different. Yes, it is S $. Sorry, S $. Correct.
Yes. Yeah.
And then is Anama bananas. So Mama bananas. Okay, so this is how, and when you condense this is known as suffix tree. Okay, so there are 3 steps. First step this, and second step this is to make the suffix tree. This clear to everyone? How to make the suffix tree? Ullas?
Yes, there.
Okay. So suffix tree we have seen, and now we go to the next concept is the Burroughs wheel transform. So Burroughs wheel transform, what do we do? The step 1 is that, for example, if this is the sequence, first you put $ in last, and then you keep on rotating till this $, comes to the last second last position. So this is the step second which you are done. Step 2 is whatever you get now, you put it sort it out and put $ in first. So you have sorted it out. And when you have got sorted it out, this last column which is there, it is known as your Burroughs wheel transformation. Is this okay?
Yes.
Okay. And now what you can do, you just have to remember only the first column and the last column. Rest all columns you can forget. Rest all these columns you can forget, and then put character wise you give the numbers. Okay, and then you can build the entire thing. Like for example, if you have to build, so you start from $. So $ comes in last. $, is here. You start from here. See the character which is here in the last column. You put that letter here. For example, in this case, it is C1. So here C1 will come. Now you come to C1 in here. See the last column, it is T1. So T1 comes here. Now you come T1 here. You see the last letter G. G1. You come to G1, then it is C3. You go to C3, it is C. C2, you go to C2, you get A. You come to A1. A1 is some column here. A1 is, so you have got ACCGT already. You got finally when you reach $, so you don't have to pay. So this is how you build like this. Any question in this Burroughs wheel like how to?
So if you don't mind 1 second, sorry, like
Yes,
after putting $.
Yes, Lakshman. So shall we solve? Shall we do one question on this?
Yes.
Okay.
Yes.
So you have got, for example, you have. I will take a small A C G A C T G. So deliberately, I have taken two of each one. So this is the sequence I have to transform. Okay. So step one is you first put dollar in last as suffix. So you get ACG, ACTG dollar. Okay. Now you do full Burroughs wheel transformation, Burroughs wheel rotation. So how you will do? First you write the first sequence first. ACG, ACTG dollar. Okay. Now what you do transformation, this dollar will come here and it slides ACG, ACTG. Now G will come here, G dollar ACG, ACT. Now it will come TG dollar ACG, AC. Now CTG dollar ACGA. ACTG dollar ACG. GACTG dollar AC. CGACTG dollar A. So dollar has come in second last. So this is your step 2. Okay. Step 3. Now you sort it out. Sort. So when you do the sorting, you put first a dollar. So it will be dollar ACGACTG. Now it will be AAACGACT. So you will take ACG first. ACGACTG dollar. Then you take ACTG dollar ACG. A is done. Now you come to C. CGCT. So CG. ACTG dollar A. CTG dollar ACGA. Now you come to G. GAG dollar. So G dollar will take precedence. ACG ACT GACT G dollar AC. So we are done. And last one is the T. TG dollar ACGAC. Is this okay? Any mistake in this? Okay. Now what do? You forget everything and you keep the first. You keep only the this one, first column and the last column. So first column is, and now you give the numbers. So this dollar is only always 1. This A is A1, A2, C1, C2, G1, G2, T1. And this will become G1 dollar, G2, A1, A2, T1, C1, C2. So you have to take only this. So, and this last one which is there, it is known as the encoding. So I have got this and I have got this. And I have to now start again from this. So what do? First I take the dollar come here. Dollar, okay, sorry. Dollar was the first one. So I do Control Z. B. So this is the encoding I got. So what do? I start with dollar. So dollar, I take the letter which is here, it is G1, G1. Now I go to G1, G1 corresponds to T1. I go to T1, comes to C2. I go to C2, gives me A2. I go to A2, gives me G2. I go to G2, it gives me C1. I go to C1, C1 gives me A1. And A1 is dollar, so I don't put it. So I have this how I have got the same. Is this okay?
Yes, clear.
Yes.
Yeah. Yes.
Okay, good. Okay. Okay, so with this we have come to the GA. So week 6 is slightly simpler. Week 5 is the only lengthy one. So here they have given a question. You are given a genome G with length of L and a set of patterns. The total length of all the patterns is new, and the average length of all the patterns is, oh sorry, this is sigma and this is new. Consider solving the multiple pattern matching problem using the brute force approach. What will be the time complexity? So see, we have got all the patterns. So this is a genome which is of length L. So one by one, if I have to pass, so it will become, and the pattern length, the entire pattern length is this sigma, and average length is nu. So when I have to pass through all, I will I have to, for the pattern matching, I will have to there do L into nu, this L, and one by one I have to do the pattern matching. So this is L nu, and how many I have to do? I have to do sigma by nu. So the complexity will be O into L nu by sigma by nu, which comes L into sigma. Is this okay? This part?
Yes.
Okay. The second one is consider the genome base and the following patterns to search and construct a try. So try, we have just done the revision, how to build the try. So this is try we always make with respect to the patterns. So we make for G. So what I do for a shortcut, you always identify like G, G, G. So first for you make for the G. So GT is same. So this gives me GTGC, GTA, GTC. Then you make for AGC, and then you make for CAGT. Only remember there is no dollar in try. And try. Okay, so in the quiz also this can come. Next question is these are patterns P1 3, P2 4, P1 P3 5, P4 6. So what can be the maximum number of edges in the constructed try? So maximum edges will become always when they are distinct. So you always make for the distinct. So this will give you 3, this will give you 4, this will give you 5, this will give you 6. So total is 3 plus 4 plus 5 plus 6 is equal to 18. The next question is, what is the minimum number? So minimum number is when all of them, they are overlapping. So this is 3, this is 4, this is 5, and this is 6. So in this case, okay, the minimum number of edges will become 6. Is this clear?
Sir, can you explain the minimum part?
Minimum is like, for example, if I tell you that there is ACG, then there is ACGT, then there is ACGTA, and then there is ACGTAC. So they have got the 3, 4, 5, 6.
Yeah.
Okay. And now you, when you build, you can build in the one only. All patterns will come A, C, G, T, A, C. Is this okay?
Yeah.
Okay. Okay. Next question is, consider the genome this, construct a suffix tree. So suffix tree we have understood, okay, how to make it. So what do you do, okay, in the suffix tree? First you make the full tree and then you condense it. Okay, like we had done with the Panama bananas. Remember, okay, there is no dollar. You don't never make a dollar separately. Okay, that is the only trick. This is easy.
Yes.
Okay. Then
Yes.
okay. Then there is another question on the length encoding, and in the live session they had given a hint that this question will come. So it is very easy. So length encoding, how do you do? This is, for example, this is the question. Length encoding. So how do you do that? Length encoding. You write it like this. Like, for example, A is 1, then G is 3, then T is 1, then C is 2, then A is 1, then G is 5, and then T is 3. And now the length of this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So she had given a hint okay, that this question might come. Okay, very easy. Just we have to understand the concept. Is this clear with everyone?
Yes.
Okay.
Yes, yeah.
Okay. So next question is Burroughs-Wheeler transform. Just now we saw we have done that. So we know the steps. Okay, put a dollar, do the transformation, then you sort out alphabetically, put dollar in first, and the last column which is there, that is the your encoding. Okay. And the last question of V6 was that there is a circular ring, circular string. So circular string is like this. So what you do, you just make the k-mers in this of okay, 3 k-mers, and you find out which is not there. So this $CC, for example, it is not there. Okay, CC dollar is CC dollar is there. Okay, there is something which is missing. So you make all the k-mers. For example, I built okay, all the k-mers, and then you can check and you can find okay, which are not available. Is this okay?
Yes.
So we can check, for example, this delta option. ATA is there, ATG is there, CC dollar is there, GCC is there, GTG is there, TAT is there, TGC is not there. So this is the one which is not there. Okay, so that's how we calculate. So with this we are done week 6. Okay, can we move forward? Anybody
Yes.
any doubt? Anyone? Any question, Jagan? I hope things are clear. Surupi?
Yes, clear.
Okay. So we move ahead with week 7. Okay. So week 7 is basically the concept is the k-means algos, and there are basically 4 concepts in this. The first is to find the hard margin k-means. So that hard margin k-means we know we have done that, but just to revise, the pseudo code for k-means is that what do you do? First you select the number of k. So this is the first initial step, which is very, very important. So for example, we have to select, for example, k is equal to 2. Then second, you select this mk, the cluster k which is point, this mk which is there, m1 and m2, to random values. Now remember, these random values, they are very, very important, because based on this, it will give you the optimal solution or it may not give you the optimal solution. And I'll just give you one example. Then the second, it has got 2 steps, k-means. One is known as assignment and second is known as update. So in the assignment, what do? You assign responsibility of every cluster, this mk, to every point. So this responsibility is given by this rk. So it will be r1, r2 in this case, and for all the points r11, r12, r21, okay, r22, r31, sorry, r13, r23. So this how you give all to all the points. So it will become r1n and r2n. So these are the responsibilities. And based on these responsibilities, now you update the cluster point. So your new cluster point will become mk is equal to summation of rkn into xn. X is not, this is not power, this is the number. Rk means to 1 and 2 and divided by rk. I'll just give you an example where rk is this. This is one example. Like in one dimension, if you got 6 points, 1, 2, 3, 5, 6, 7. So n is 1, 2, 3, 4, 5, 6. This is the graphical presentation. And for example, you have selected k is equal to 2, and your initial cluster points are m1 is 10, m2 is 5. So this is your assignment 1. So the first point 1 will go to 0 because it is not assigned to 10, because the distance between 10 and 1 is 9, whereas 5 and 1 is 4. So it will be assigned to R2. So this is like this. Similarly, R12 will be 0, R22 is 1, R13 is 0. So see, all the points which are there, they are close to M2. So all will be assigned to first point, the second cluster. Now you do the update. So your M1 will become, sorry, this M1 and M2 here I've done, M1. Now your M1 will not change because nothing has been assigned to M1, it is 0. But your M2 will change. So M2 will become all the summations, because all are assigned. 1 plus 2 plus 3 plus 5, 6 plus 7 divided by 6, it becomes 4. And your M1 remains 10. Now similarly, in the second iteration, your responsibility for M1 will be 0, whereas for 2 will be 1. So all points will be closer to 4 than 10. Therefore, now there will not be updation, no updation for M and M1 and M2. So see, due to the wrong selection of the initial points, due to this wrong selection of initial points, all points have been assigned in cluster which is M is equal to 4. Is this concept is clear?
Yes.
Okay, so that's why your initial selection of cluster points is very, very important. Then only it will converge. Okay. वैसे तो it has converged, but it will not give you the optimal solution. That is the point. Okay. So now, if you take, for example, M1 is equal to 2 and M2 is equal to 4, and you follow the same principle, then it will give you the optimal solution. Then it gives you M1 becomes 2, and your M2, which was 4, when you do the update, it will become 6. And thereafter, there is no change. So it has converged to 2 and 6. So this is the basic concept of your hard margin, hard margin K-means. Now, what is the difference between hard margin and soft margin? Hard margin K-means we were doing the hard assignment or the hard responsibility to every point. In the soft K-means, what we do, every point contributes to both the clusters by softmax function, and the softmax function is given by this. Just you remember this from the quiz point of view. It is just softmax function. This is beta, distance 1, distance 2, distance 2, distance 1, distance 2. Any question on this?
No, sir.
Okay. So this, what we have done, that conceptually, I'll just give you one example. That in the hard means what we were doing. Hard means what we are doing. These were the points, for example. So it was finding a difference like this. It was giving you one cluster like this, and one cluster was this. So it was not able to identify this in this cluster. Okay. In the soft K means what we are doing. Soft means only the difference is then what we were doing earlier, R1 1 is equal to 1 or 0, which we are doing, and 1 or 0. Here what we are doing, this R11 which is there, we are giving responsibility to both the clusters by the formula of e to power minus beta d1 divided by e to power minus beta d1 plus e to power minus beta d2, and R21 Basically, the responsibility to cluster 1 by 0.1, the responsibility to cluster 2 by 0.1 is e to power minus beta d2 minus beta dv1 plus e to power minus beta dv. So therefore, this 1 point which is there, it has responsibility to both cluster points, to this also and this also. This is the only difference. Rest your update and everything, it remains the same. Is this okay with everyone, this concept?
Yes.
Okay. Okay. So update remains the same. Mk is equal to summation of Rkn to x to n, which is xn is the not the power, it is the number of that point divided by Rk, whereas Rk is equal to summation of Rk n is equal to 1 to n. Okay, this is the only difference. Okay, then the next important concept which was covered was a probabilistic mixture model. That in the probabilistic mixture model is what? That if you are given some points, for example, you are given x1, x2, x3, up to xn, we are told that it is coming from, for example, two mixtures of Gaussian distribution. Okay. And now, depending on these points, we have to estimate mu1, sigma 1 square, mu2, and sigma 2 square. I'll request everyone to keep their mic off, please. Yeah, thank you. So this was the basically concept which was covered in the lecture, that we are given some points and we are told that they are coming from two Gaussian distribution. So it is a mixture. So it is like this, we don't know. So these are two Gaussian distributions and the points are here. So points we are given and we have to estimate the mean and the standard deviation of the Gaussian distribution. So this is the concept. So what we know from our MLF and MLT foundation course, that if we are given these points and if we are told, for example, that they are coming only from one Gaussian distribution, that x1, x2 up to xn, they belong to some Gaussian distribution n, mu sigma square, then we know, without going into the derivations again, that mu will become sigma of xi by n, and sigma square is xi minus mu square summation divided by n. So please remember this formula. Is this okay?
Yes.
Okay. Now, in the question in the live session, I had seen some clarification, and they had told that in case some different type of distribution comes, so they will give this CDF ka jo formula hai, they will give it. Okay. And if you go to your MLF foundation basics, so we had covered, okay, for all the distribution, uniform distribution and all that. Okay. Now with this background, if we are told that there are two distributions, then how to solve it? So that is solved by something called EM method. EM method. So what we do? We have got points x1, x2, x3 up to xn. We randomly choose and we say that they are coming from two. So one is n mu1 sigma 1 square, another is mu2 sigma 2 square. So now what do? We select randomly select mu1, mu2, sigma 1 square and sigma 2 square. Okay. And now every point which is there, x1 to xn, it is equal to some weightage of n mu1 sigma 1 square plus some weightage of the second distribution mu2 sigma 2 square. So now with this randomly selected points, we find the responsibility of every point towards both distributions. And how do we do that? We do R1 of to 1 is equal to weightage of 1 to n of nu1, nu2 divided by total weightage and nu1, sorry, sigma 1 square plus weightage of n of nu2 sigma 2 square. This is first responsibility, and second responsibility is R21 is equal to weightage of 2n into nu2 sigma 2 square. Denominator remains same. And now, depending on these two values, this is the assignment. And now, depending on this responsibility, the second method is update, which is the M. So this is E, this is M. This is the crux of the lecture. Is this okay? And why we were taught this? Because this is very, very similar to our soft K means we were doing the same thing. We were assigning two responsibilities and then we are updating. Okay. So on the basis of this, professor told us, covered us like this, that earlier in the hard mean or soft mean, we are making the circular clusters. So now making the differences in this, tweaking these formulas, now we can make elliptical also, like this. Okay. This is the only thing. Is this okay?
Yes.
Okay. So these are the basics of your week 7. Basic formulas and all that. So GS you can all go through. Okay, GS are easy. And what I feel, it is slightly becoming heavier. So week 8, can we keep it for tomorrow?
Sure.
Okay. So can we call it this session off now?
Yeah.
So week 5 to week 7 are clear. Any question on this from anyone?
No question. We'll do the PYQs tomorrow, right?
Yeah. Tomorrow we'll do the PYQs. Okay, so what I remember, okay, many of you are in the corporate finance also. So I have left like a week 8 of corporate finance also and week 8 of this also. So tomorrow somewhere suitably, maybe somewhere in the afternoon, maybe around 1 o'clock in the afternoon or 2 o'clock, we will cover both them and we'll solve the PYQs also. Is that okay?
Okay.
Okay. Thank you. Thank you for joining in. Thank you. Have a very nice day. Bye-bye.
Thank you.
Thank you, sir.
Bye.